Right, so guys, 3D printing. This is my 3D printer, and the print table there, I can print 450 by 450, so good size printing bed. Heated. It's got a heat matting underneath it. That heats it up to anything up to 60 degrees, so it can be quite warm. At the moment it's 35 degrees. It just helps the plastic stick to the bed. Just a pretty basic extruder setup. Stepper motor, good quality aluminium feeder. Plastic 1.75mm plastic feeds straight into the feeder. Good solid tube fixing all the way down to J6 head, which I find I did upgrade to a modern sort of like triple fan quadruple thingamajig, and within 2 days I'd switch back to the J6, because just a really good printing head. This is not a fine detail printer. Whoops, come out a bit. Yeah, it's not a fine detail printer. It's more for printing engineering parts. So when I was working in the industry, basically company would contact me and say, Dave, we need a plastic bracket for this, or a thing for this or a thing for that. Can you sort us out something? And all I do is draw it, send them the drawings, and then they would manufacture it in aluminium, plastic, whatever material they specified, and then there'd be 3 or 4 weeks, sometimes 5 weeks, 6 weeks, to-ing and fro-ing, saying, oh, alter this, alter that, alter something else. So and we're not all perfect. I get little bits that's not right and one thing and another, so yeah, take a little while to get the actual prototype up and running. So I found by building a 3D printer I could print the parts in plastic, check the sizes, check the use of the product, make sure the product was or the part was serviceable, and then send them the part, and then it cut down a lot on the messing about, really. So but a lot of it is with prototyping design, a lot of it is the concept. Someone has a concept of a part, a product or something, and when it actually materializes in a solid object, that concept changes a little sometimes. So providing I always find the main thing is that the product actually works, does what it says on the tin. If it does that, then you've got a good product on your hands. If it's just a thing, then and it serves no purpose, I don't see any reason for it being. Anyway, yeah, I think the Chinese and the Japanese got it right. The guy that took me on my engineering apprenticeship, he said the Japanese are very clever people. They let the English and the Americans and the Germans do all the work, and then they pick up a product that they've designed and manufactured and spend all their money on improving it. It's not a bad concept, actually. So when you're looking at designing something, or you need something to do something, look what's on the market already. Take a look at their designs, their ideas, their concepts, and improve on it. That way you save a lot on the initial costs of setting up the design. So yeah, very rewarding work to see your ideas come into life. yeah, and actually see what good it does for people. I think the best design work I'd done was at a place called G&S Smurfwaite's, Heathfield, Newton Abbot. He designed, or he came up with a concept for special furniture for disabled kids and people with special needs. And I think he started off doing school desks and that sort of stuff, and then developed it into special needs products. And yet he had a product called the Heathfield chair, and to obviously children with special needs all have special sizes and shapes and needs for that particular chair, so we basically build a chair to suit each individual person. Yeah, it's really rewarding work, that. Yeah, so that's the actual printing side of it. It's basically laying down a film of plastic. It's 238 degrees at the head of the nozzle. That's melting that plastic, and it's laying a film of plastic 0.28 thickness. So call it 3mm, 369, so it has to do 4 layers to make a millimetre. Yeah, 4 layers to make a millimetre, so if that one's 100 millimetres high, and you're looking at quite a few different layers. Yeah, so what's actually printing at the moment was on the stern doors, where you come into the stern doors and down the steps. There's cupboards each side, and I put the pin locks in for the put the pin locks in. That's the pin lock there. Basically got 2 of them on each side, goes in, locks the hatch down, so nobody can open the hatch when I'm not on the boat. There's 2 of them. Key goes in there, and that's how they lock. Well, I put doors on the cupboards that as you come in the front doors now, so before I was resting or leaving those, storing them on top of the inverter, but now the inverter's got doors on it, the cupboard's got doors on it. I've got to open the door to put them inside, which is a bit of a pain in the bum. So I'm basically printing a bracket that will fix to the wall somewhere there, or somewhere in there, on a ceiling or somewhere, where these are going to stand in. Imagine that hole there, that's going to go in there, and they'll just drop in. 2 of them will drop in like that, stand up, and then when I go out I just take them out, put them in the door, and when I come back in just drop them back in the hole. Basically it's just a bracket to hold those lock pins. So I don't think there's anything on the market to be able to do that. If I didn't have a 3D printer, I'd probably have to find a piece of plastic bracket or something and alter it to do the job. With this, with having a 3D printer, you can make whatever plastic bits you need, which can be handy sometimes. There's something I printed there. I don't know if you can see that. There, that's basically a, I'll zoom out a bit. That there's basically, it's a plastic vent for it's for covering up the mushroom vents where it comes through the ceiling. And what happened, what I found was I wake up in the morning and find a wet patch on the bed. Think, oh, I've had an accident, but no, it's not. It's drip, drip, drip coming out of the mushroom vent in the bedroom. So what this basically does is it clips into the tubing. There you go, that's the plastic tubing. This is the plastic tubing that fits up into the ceiling, and then basically that pushes up into there, just like that, and the water comes, the condensation forms in here, and it runs down this pipe, basically, like that, and that little gap that's there, it runs down on the inside of the pipe, goes in there, and it gets caught into this tray, and it fills that tray up. And luckily enough, I find that the depth of that tray, it was a lot deeper at one point, but I've redesigned it and brought it down a bit now, because it doesn't really fill that tray right up. In the morning, all I have to do is unclip it, and I've got a floor cloth in the front of the boat where I keep all my cleaning stuff, and I just basically tip it onto a floor cloth, and it's the amount of water that's in there just soaks up into the floor cloth, and I put that in the mop bucket. So basically that stops me getting a wet patch on the bed every morning. And same in the kitchen, I've got them right the way through the boat, living room, kitchen, the lot. I think it's a good finish to the end of the ceiling. So yeah, that's basically what that's, and that was 3D printer. Without a 3D printer I wouldn't have been able to print it. So yeah, they are quite useful, extravagant but useful. And then I say extravagant, if you go and buy a 3D printer from a shop, then it can cost you anything between a 200 by 200 print platform probably starts at around 200 quid, but anything to be able to print this sort of size, you're looking at 6 to 8, maybe 9, and then an industrial type printer like this one with a 450mm print size bed, you're looking at 1,000, maybe 2,000. But the actual electronics and the linear motion systems all pretty much the same. It's just a matter of it being bigger, really. Software and that's all open source, so not vast amounts of money to pay on the software. And I'm lucky enough that I've worked in CAD quite a long time. So my software licenses, I've got open software licenses on a fair bit of software, which is handy to have instead of having to buy very expensive software. I've got software licenses where when I work for companies, I still carry my same software license, so it's that's handy, very handy. But there are software packages out there, free software packages out there that you can quite adequately design and run a 3D printer on. So yeah, it's not Doesn't have to be expensive. There are ways of keeping the cost down. So we'll move you back from that. We'll go on to the drawing side of it, maybe the CAD side of it, show you some of the CAD side of it. Right, okay, so let's move you from there. So this is the so this is the software for printing. This is the software for printing the things. Basically, that's all the G coding that runs is telling the machine what to do. You see a basic line there, that's basically temperatures that it's checking. So every 3 seconds it checks the temperatures and adjusts those. Temperature settings are here, running at 210 at the moment. The actual temperature is 209, 210. And then the bed temperature is 29 degrees to 30 degrees, set to 30 is 29 degrees, bounce up and down, and the fan's running at 78%. You can do fine adjustment. There's settings here where you can do fine adjustments. Basically that part's 29% finished, 67 minutes to print it. Its filament length is 17,890 millimeters. 107. Let's have a look. 178.19.4 millimeters long. So it's about 1 meter 800 long. The filament to print that part. Material costs £2.64. It's cost me £2.64 to print that bracket. And a 1 kilo roll of that plastic there, which is a peg material, 1.7 millimeter peg, and it's about 16 quid a roll for a kilo roll. So it's cost me £2.64 that bracket. Here's another bracket that I printed there. Basically, there it is. That's the type of finish you can get on them. It's not too bad. A little bit of cleaning up and some plastic spray. There's a gloss spray that you can get that sprays onto these plastic parts. Just watching the blogs of people putting their windlasses on the top of the lock gates, and then closing the lock gates and the windlass dropping into the canal. And they all have, some have these leather strappy things that they hang them in, and it always looks as if it's about to swing around and catch you in the nuts, so or on the leg or whatever. I just thought I'd have a go at designing something where I could where it would make it easy. So basically that's the bracket, and then the windlass is the standard windlass that you get. Basically that goes through the hole and clips in like that, and that holds it, stops it, doesn't drop out. And then for actually fitting it, get it down a little bit more. And then to fit it, basically you grab your windlass, close it like that, and that basically goes on like that, and that's it. Take your windlass out, use your windlass, drop him back in, and that's it. That's basically how it works. It can slide off like that, so what I've done is, if you to make it a bit more secure, I wear quite a finished belt. You take your belt, put it over your belt. You don't have to unthread your belt to get it on. There it is. You take your belt goes over that. Lift your belt up and it's on. Not going to come off then, it's quite secure. That's how it works. It's pretty solidly held. Sticks at the back a bit, so got to be careful if you're reversing into anything. Yeah, so that's basically how it works. It comes in handy, and I say 3D printed, so what can I say, it's not a bad system. Okay, first thing we need to do is to make a cup of coffee. Yeah, okay, right, there you go, 1 cup of coffee. Don't know what it is about cab work, we always need a cup of coffee. Let's zoom in a bit better. Right then, so that's our CAD model, basically. Okay, I'll zoom him out just a touch. There, right. Here's a cab model. So basically, to draw that, it's look at the front. That's the front view. Bottom, side view, top view. There you go. That's it there. Right. So to draw that model, basically, with this program, we select a. You start a 2D sketch. And you select the face to put it on, and then basically start again. So draw a circle like that, yeah. And then you pick 3D, and then you select okay, that'll add that to there. You can fillet it, so stick that on there. Let's make that 8mm. Apply that. And then let's say you want to put a sketch on there. Let's do a square. Like that, and then 3D model. Select that. Let's say we want to cut a hole right through the model. Like that. It's all. And it's there. So then when we look at the model there, see, that's a hole right through. There's a knob on the front. Not that we want that, but that's basically how we model. Let's undo all that. Right, that's back to our basic model. So to draw this model, we start sketch 1. That's sketch 1. And then we go to 3D model, extrude. Like that. So the first extrusion on that sketch is the thickness of this top piece here. Sketch like that. Second sketch, so we sketch on this face, on this plane. Yeah. And we sketch on there just this square bit on the bottom. So basically we look at the front view there. Basically what we're sketching is 65mm, 15mm from the top of there, 50mm wide, and that's then extruded out. That's extruded out to here. I don't know what the extrusion is on that one. 30mm, that's the extrusion there. So the sketch goes on there, that's extruded out like that. So that makes that part. After that, we need to chop some holes in it. So that's hang on, cancel that. Yeah, that's that one. So the sketch there is now, that's that one there. So we cut 2 holes in the thing. That's to mount the screws for mounting. That's that. Close that one down. The next one is we chop 2 holes down through. That's for the pins to slide down into. So that cuts 2 holes down into there. You see at the bottom. There you can see that's the 2 holes it cuts in there. Then the next one are the 2 blocks, or the 2 shapes there. Cancel that, do that. That's basically the sketches of what we want to do there. That's all okay, so that does them. That's how that works. Sketch those. Put that back to 3D model. Then after we've actually drawn our rough sketch, that's when we start fillet. We can fillet edges. So if I delete that fillet there, right. So basically what we've got is a square. It will all be square blocks. Yep. Delete that one. So that's how basically the 3D model's expanded and subtracted from to make that 3D model. And then to fillet, we got an 8mm fillet, so that's that one open that one. Okay, that's 2 fillets there. Then we fillet again. We drop the size down to 2 mil. And we fillet this, 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 and this. I like to fillet these areas here because it gives you a stronger joint there. Well, you got a 90-degree joint there. By filleting that, it just helps to support this joint along there. Because these are, although it's a solid, these are printed as 2 separate entities, for want of a better word. Okay, and that's basically how it's done. Then from there, we save it, and then from there we go to environment, 3D print, and that's our model in the 3D printer. We save it as a still file, and it's saved there as a still file. Then after that, that's the 3D model. We exit that. Exit out of that. Then we open up our 3D print. 3D print. There, that's the model. We import the model, so remove that model. Import a model. The model is door lock pin. Open that. That's our model imported in. Okay. And then we prepare to print. That's the model being ready for printing. And then basically that's how the model's printed. Here it is, printing the 2 holes there. And as it comes up, it will put a base on the bottom there. That's printed up to there. Then that's printed over there. And that's the basic 3D model there. On that one, shall we? Yeah, so there's the outdoors mounted. Another one exactly the same going in here. And then this switch panel is going to be mounted on the door like that, through the door. And then when you open the door, the cables will be brought over to here and like that, but not that side, it'll be on this side here. So the actual switch panel is going to be mounted in the door like that, and then you can open the bottom part of the door. There'll be a cut line on the door along here. Door's going to be cut along here, and then there'll be open the top of the door or the bottom of the door. If I open the bottom of the door, I can control the solar, switch the batteries off, and adjust the inverter. And then if I need to open the whole door to get at the anything up there, this switch panel here is now going to come out through the face plate here, so that will be switchable. That switches from off, shoreline, generator, inverter, so that works that out. And that's a galvanic isolator up there. That's the fuse box. There's all the cables and everything there. And then in the bottom of there we've got our let's see if I can, that's our batteries. So we've got 16 batteries in there, 16 3.2 volt batteries. That's 412 volt, 224 volt, and 148 volt. There's a 48 volt battery in there. There you go, 16 cells there. all sitting at 1324 at the moment. It's running the power at the moment, so it's running the power at the moment. Television's running, the CAD's running, 3D printer's all running off of this battery at the moment. So that's the secondary one, which will be set up. That battery will be going in the space down there. So we'll have two 48 volt batteries running there, 150 amp hour batteries. So that's basically, it's now charging. There he is now. Now I've switched the 3D printer off. Instead of taking the power from the battery to operate the 3D printer, it's now charging the battery there. 1819. Okay, right. Let's shut this door because it's getting rather cold. That's that one. Got to get handles on these doors, so it should be